This is electrolysis of water. So what I've done here is I've filled these two tubes with distilled water. And I did that by pouring the distilled water into this separatory funnel. And then the water went down through this black tubing into this tube, went down both sides, and then went up to the top. And so I have some little stoppers here that are holding the water inside the tubes. So now I've got electrodes down here that are attached to a power source. And when I turn the power source on, electricity is going to move through these leads into these little platinum electrodes, and then it's going to have access to those water molecules. So let's turn it on and see what happens. I'm going to zoom in here so you can see the bubbles that are forming at the electrode. So there's one electrode, and those bubbles are rising because that gas is less dense than the water that's inside the tube. So the bubbles are going up, and we have bubbles coming off over here as well. Not quite as many, but definitely bubbles in both. So those are going to go to the top. Now we're going to let this run for about 45 minutes and collect that gas at the top of the tube. So if we follow those tubes up to the top, those gases are going to collect right here and right here. So we're going to come back and see this in about an hour, and then we're going to test each gas to see what it's made of. I just turned off the electricity. So before we light the different gases that are inside the tubes, I want to point out to you that, because I know it's hard to see, this tube has this much gas. Remember, the liquid was at the top when we started, so this tube is now full of this much gas, and the other tube is full of this much gas. So the liquid level is here. So we're going to light the gas that's in each tube and see what it is. So if those gases are water, let's say the electricity boiled the water, then when I put fire near that water vapor, then we know that we have a physical change, and what we've done here is a physical process instead of a chemical process. If we light the gas and it makes the fire bigger, that means we have oxygen in the tube. If we light the flame and put the gas on it and it explodes, then we have hydrogen. So that's how we're going to know what we have going on. So I'm going to light my little wood splint, and let's see what we have here. If I hold the splint above this tube and add gas, it reignites. And that's how we know that this gas is oxygen. It makes the flame glow brighter. On the other side, if we released hydrogen or oxygen, we know we released hydrogen, so listen carefully for the hydrogen bark. So we're not igniting a whole bunch of gas at one time, so that's why we don't have a huge explosion. But you experienced the hydrogen explosion with fire when I filled at Halloween the eggs full of hydrogen gas and exploded them. If you take that hydrogen gas and put it into a confined space and ignite it, then you get your big explosions. And so what we did here with electrolysis is we were able to break the bonds holding the hydrogen to the oxygen. So we created two different types of gases, and that's how we used electrolysis to separate water into hydrogen and oxygen.